Hello, everyone. Welcome to this short video on learning mathematics through concepts and examples. Today, we are going to look at some of the example problems from limits and continuity. So here we have our first example. Find the following limits using the graph. So the graph of the function is given here, and we are asked to find the limit. So the first part here is we have to find the limit as x approaches to 3 from the left. So that means if you look at this graph here we have 1, 2, 3. 3 is there. So when x approaches to 3 from the left like that, okay, when x approaches to 3 from the left, we see that this graph, it goes like this. It goes all the way down. As x gets closer and closer to 3, this graph gets down like this, and it goes all the way up to negative infinity. That means the first one, that is limit as x approaches to 3 from the left of the function, is negative infinity. Similarly, we want to find the limit in part B, limit as x approaches to 3 from the right. When x approaches to 3 from the right, from this side, when x approaches to 3 from the right here, you'll see that this graph, when you come from the right side, it goes all the way up like that. Okay, it goes all the way up like that to infinity. So the limit as x approaches to 3 from the right of that function is positive infinity. Is positive infinity. So that's how we can find the one-sided limit. Limit as x approaches to 3 from the left and x approaches to 3 from the right in this case. Okay, let's look at next example. Here is our next example. This is also based on the graph of a function. Graph of a function is given here. In part A, we have to find the limit as x approaches to negative infinity. So what we are looking at is the value of x is going towards negative infinity like that. When x approaches to negative infinity, if you look at the behavior of the graph, this graph is going upward like this. That means this graph will go all the way to positive infinity. So this will be positive infinity. Similarly, if we want to find the limit as x approaches to positive infinity, if x goes towards positive infinity on this side, right? When x approaches to positive infinity, if it goes this side, what we see is this graph goes upward. This graph is going all the way up and it continuously increases. That means when x approaches to positive infinity, the function value also goes to positive infinity. So that's how we can find the limits at infinity. In this one, we calculate the limits at infinity, limit at negative infinity and limit at positive infinity. And in the previous example, what we did is we calculate limit at 3, a finite value from both sides, and the limit values are infinity. So the first example was infinite limit, and the second example is from limits at infinity. Limits at infinity is also known as the end behavior of the function. Okay, let's look at another example, which is also based on the graph of the function. Here is that. Find the following limit using the graph. So you can see that here is the graph of the function, and we are asked to find the limits at infinity. Now in part A, we have to find the limit as x approaches to negative infinity. So when x approaches to negative infinity like that, when x goes towards negative infinity, what is this function doing? We are looking at the behavior of the function. We see that this function is getting closer and closer to a horizontal line here. Okay, it is getting closer and closer to that horizontal line, which I have shown here in red. And if we count, this is 1, 2, 3 units below the origin, meaning of that is this is y equal to -3. Okay, it is approaching, the function is approaching a y value of -3. That means limit as x approaches to negative infinity of that function is -3. And if we look at the other one, when x approaches to positive infinity, okay, if x goes to positive infinity, this side, when x goes towards positive infinity, we have to look at the graph. So over here, the graph is down here, and you can see that the graph is increasing like that. It's going up, and also it is reaching, or it is approaching closer and closer to the same line y equal to -3. That means the limit as x approaches to infinity of the function is also -3. So this is also -3. So what is this giving us is when x approaches to negative infinity, we approach to -3. When x approaches to positive infinity, we approach to -3. That means this line here, y equal to -3, is the horizontal asymptote to the graph of the function given here. So that's how we can use the graph to actually compute the limit. And we can find both the limit at infinity and infinite limit easily using the graph. Okay, now let's take an example where we can find the limits at infinity for a problem when the graph is not given, like this one. Okay, here we want to find the limit as x approaches to infinity of 5x raised to 13 over 7x to the 10 plus 31x to the 13. So the best trick here is, you can see that we in the numerator we have x raised to 13. In the denominator we have x to the 10 and x to the 13. So what we need to do is we need to divide all these, everything in the numerator and everything in the denominator, by the x with the highest power. So you can see that the x with highest power in the denominator, okay, x with highest power in the denominator is x raised to 13. So we have to divide everything by x raised to 13. Let's see what you mean by that. Limit as x approaches to infinity. So in the numerator, it will be 5x raised to 13 over x raised to 13. We are dividing by x raised to 13. And in the denominator, we have 7x to the 10, 7x raised to 10. We divide that by x raised to 13. Then plus, we have 31 x raised to 13. We are also dividing that by x raised to 13. So what we get is limit as x approaches to infinity. In the numerator, x raised to 13 over x raised to 13, that's a 1. 1 times 5 is 5. And in the denominator, we have a 7. So x to the 10 divided by x raised to 13 is x raised to 3 in the denominator. Then plus, over here, x raised to 13 and x raised to 13 cancel. So that becomes 1. And 31 times 1 is 31. So now we can compute this limit by direct substitution. We can perform direct substitution and find the value of that limit easily. So if we do that, what happened is we have 5 in the numerator, and in the denominator, when x is very large, okay, and cube of that will also be very, very large. And 7 divided by a very large quantity is approximately 0. So that becomes 0, and then plus 31. So our limit is 5 over 31. So remember, if you have to find the limit at infinity and a rational function is given, always divide every single term in the numerator and denominator with the highest power of variable that you see in the denominator. X with the 13 is there, so we divide by x raised to 13, not just by the power, but with that x also, okay, with that variable also. In this case, x raised to 13. Okay, that's how we can find the infinite limit if the graph is not given. Okay, let's move on to next example where we look at the continuity of the function. So let's see. Use the graph below to determine the value of x at which the function is not continuous. If you remember the basic meaning of continuity of a function is continuous if there is no hole, no break or corner in the function. So clearly we can see that here is a hole in the function. There is hole in the function at, let me use a different color. There is hole in the function at x equal to 6. And there is break in the function over here. We have break in the function over here at -3. So that means this function is not continuous at x equal to -3 and x equal to 6. So we say that given function is not continuous. Okay, given function is not continuous at x equal to -3 and x equal to 6. So one more time, for the function to be continuous, there should not be hole, break, or corner in the function. So in this graph, we have a hole at 6 and we have a break at -3. That's why the function is not continuous at -3 and 6. Okay, let's analyze one more continuous function problem. In this case, the graph will not be given. So like this one. Okay, for what value of c, we have to determine the value of c. What value of c is the function f of x equal to this one, continuous at -4? So first of all, when x equal to -4, the value of the function is c. When x equal to 1, the value of the function is 6. And otherwise, this is the value of the function. But this can be simplified. So let's try to simplify that first and see what we get. If you look at the numerator, we have x squared minus 16, which can be written as x plus 4 times x minus 4. And in the denominator, we have x plus 4 multiplied to x minus 5. So clearly, you can see that x plus 4 get canceled. And we are left with x minus 4 over x minus 5. So that is the value. Now what I'm going to do is I'm going to represent this in a number line so that this will make a little more sense. Say, for example, we have a number line going from -infinity up to infinity. And they have given here the value of the function at -4. If x equal to -4, maybe somewhere here, -4, the value of the function over here is c. Okay, the value of the function over there is c. And at x equal to 1, the value of the function is 6. Value of the function is 6. Otherwise, the function is this one, x minus 4 over x minus 5. That means in this interval here, okay, in this interval here, the function is x minus 4 over x plus x minus 5, x minus 5. Similarly, in this interval, it is x minus 4 over x minus 5. And also in this interval, the function is x minus 4 over x minus 5. That is the meaning, okay? At at -4, the function value is c. At x equal to 1, the function value is 6. Otherwise, okay, that means excluding those 2 points, the function value is the function is x minus 4 over x minus 5. So in this interval, x minus 4 over x minus 5. In this interval, x minus 4 over x minus 5. And in this interval, x minus 4 over x minus 5. And we want to find the value of c so that the function is continuous at -4. So if we want this function to be continuous at -4, there should not be whole break or anything. That means on the left, we have x minus 4 over x minus 5. On the right, also, we have x minus 4 over x minus 5. So value of those two should be equal to c at x equal to -4. So we can say that this is what we can say. For the function, okay, for the function that is f of x to be continuous, at x equal to -4, x minus 4 over x minus 5 must be equal to c, And this is true at x equal to -4. That means we can plug in -4 here to find the value of c. So that means the meaning of that is, or c is equal to, so we can plug in, this is -4 minus 4 over, again, that is -4 minus 5, which is equal to -8 over -9. And when you divide negative by negative, it's positive. So that becomes 8 over 9. So meaning of that is the value of c is equal to 8 over 9. So if the value of c is 8 over 9, the function is continuous at -4. That is the meaning of that. So we can actually determine whether the function is continuous or not by plugging in the values to see whether it creates break or hole. But in this case, they have already given the piecewise function. So for this to be continuous, the value over here should be the value on the left should be equal to the value on the left and value on the right. That's why we set up this equation and we solve that by plugging in x equal to -4 to get the value of c. Okay, so that's about the continuity of the function. Now we have the other thing that we want to check here. That is the intermediate value theorem. Intermediate value theorem is one of the big concepts in calculus. So let's talk about the intermediate value theorem. So the question here is use the intermediate value theorem to show that, okay, the function which is given here has a 0 in this interval 0 to 2. So what you have to do is, if you want to do that, first we have to check whether this function is continuous on that interval or not. This is a polynomial function. Polynomial function is continuous everywhere. So we can say that f of x is continuous. Okay, f of x is continuous. Continuous on this interval. If f of x is continuous on this interval, we find the value of f of 0 that is on the left hand and also on the right hand. And they should have opposite sign. One should be positive and one should be negative so that the 0 lies in between. So let's find f of 0. You plug in 0 there. F of 0 is equal to, we are plugging in here. So 0 squared plus 2 times 0 minus 1, which is equal to -1. Okay, so f of 0 is -1. Now we have to find f of 2. And if f of 2 is positive, then we can say that the 0 is in that interval. So let's plug in 2 to that function. F of 2 is equal to 2 squared plus 2 times 2 minus 1, which is equal to 2 squared is 4. 2 times 2 is also 4. 4 plus 4 is 8. 8 minus 1, that is a 7. So clearly you can see that f of 0 is negative. That is, f of 0 is less than 0. It's negative. Whereas f of 2 is greater than 0 or positive. Is greater than 0 or positive. Meaning of that is there is a root. There is one value in between. Okay, there is one value in between which will be 0. That's why we can say that the function has a 0 in that interval. So intermediate value theorem, sometimes referred to as IVT, can help you to determine whether there is a 0 in the given interval or not. So this is how we can find or we can apply the intermediate value theorem to determine whether there is 0 in the given interval or not. Okay. Now the last thing we basically work in the limits in calculus 1 is the epsilon delta definition of limit. We are not going to do the proof or anything like that, but we are going to determine the value of delta when the graph is given. So if you look here, use the graph of the function f of x equal to x squared. So this one is y equal to x squared or f of x equal to x squared that is given to you. We have to find a delta such that x squared minus 1 is less than 0.2. So x squared minus 1, this is the function value, is less than 0.2. That means here it is. Here is 1, okay? And then if you look at the function value here, if you want to go from 1 up to 0.8, that is a difference of 0.2. On this side, if you want to go from 1 up to 2, that is also 0.2. Okay, so that is this one, the function value minus 1. That is basically we are doing the math at 1. So 1 squared is 1, is between -2 and -0.2 and positive 0.2. That's why absolute value of x squared minus 1 is less than 0.2. What we are asked to do is we have to find the delta. Delta is this number here. So this distance here, down here, okay, that is delta. But what happened is sometimes these numbers may be different. Maybe these numbers are not the same. Maybe the first one is delta 1 and second one is delta 2. If that is the case, then your delta will be minimum of those two. Minimum of delta 1, okay, minimum of delta 1 and delta 2. So let's try to do the math and find this. So in order to find this delta, the x value, because these are the x values, right? X is between certain two values. 1 is between certain two values. So x is there. So how we can find that is by solving this inequality. That's all we need to do. So we have absolute value of x squared minus 1 is less than 0.2. Meaning of that is if you use the definition of the absolute value, we can say that x squared minus 1 is between negative 0.2 and positive 0.2. We can write this as negative 0.2 is less than x squared minus 1 is less than 0.2. We are looking for the value of x. So what we need to do is we need to add 1 everywhere. So if I add 1 here, it will be 1 minus 0.2, which is 0.8, is less than x, because x is squared. So if you add 1 here, 1 and 1 cancel, we are just left with x squared. Is less than, if we add 1 here, then it will be 1 plus 0.2, that is 1.2. Note one thing, you basically get these numbers, 0.8 up to 1.2, that is x squared. The function value is between, or the y value is between 0.8 and 1.2. That is the meaning. So if that is the case, what is the x range? What is the range for x? That's what we want to find. So if we want to do that, what we basically do here is x squared. If you want to find the value of x, you need to take the square root. So we take a square root here, we take a square root here, we take a square root there. So this will give you the square root of 0.8 is 0.8944 is less than square root of x squared, that is simply x, is less than, if you take the square root of 1.2, that is 1.0954. So we are getting these values. The lower x value where I'm pointing is this one. And then the upper value, the upper x value where I'm pointing is this one. So what are the values of delta? You can clearly find delta 1 is equal to, the first delta is equal to, it is 1 minus the lower value. That is 1 minus this one. 1 minus 0.8944, which is equal to 0.1056. And if you want to find delta 2, it is this upper value minus 1. Upper value is this one. I mean, this one, which is 1.0954 minus 1. That will be equal to 0.0954. So you can clearly see that these numbers are not the same. So your delta will be minimum of that. So delta is the minimum of those two values, minimum of 0.1056 and 0.0954. And if you look carefully, the smaller number is this one. The second number is smaller. So that is your delta. So delta equal to 0.0954. So remember, whenever you are asked to find the value of delta, when the definition for epsilon is given, this 0.2 is the epsilon, all you need to do is solve that equation and then find the value of x, the range for x. That will give you two delta values if the interval is not symmetrical. And the minimum of that is your required delta. I think we can do one more problem like this so that this concept will be a little more clear. Okay, let's go here and check it. Here we have a similar question. They have given a function. Okay, they have given a function f of x equal to 1 over x. And then you can see that the value of the function is between 0.15 and 0.35. So that means f of x minus 0.25 is less than 0.1 because 0.35 minus 0.25 is 0.1 and also 0.25 minus 0.15 is 0.1. We have to find the delta. Delta is the minimum of these two distances, minimum of delta 1 and delta 2. That is your delta. Delta is the minimum of delta 1 and delta 2. So we need to solve this epsilon equation to find the equation for delta so that we can find that delta. So let's begin. So what we have is this one, f of x, the absolute value of f of x minus 0.25 is less than 0.1. But f of x is 1 over x. So we can write that as 1 over x minus, I'll use fraction because um, sometimes that will be helpful. Like 0.25 is there. This is 1 over x. So if I use fraction, it will be a little more easy for me to handle that. So 0.25 means 1/4 is less than 0.1 means 1 over 10. 1 over 10. So meaning of that is this quantity inside the absolute value is between negative 1/10 and positive 1/10. So we can write that as negative 1/10 is less than 1 over x minus 1/4, which is less than 1 over 10, because we are writing that quantity between negative 1/10 and positive 1/10. Now, in order to find the x, what we can do is first we can add 1/4 everywhere. So if I add 1/4 here, that will be 1 over 4, right? Because I'm adding 1/4 to get rid of this one. So it will be 1 over 4 minus 1 over 10. So 1/4 minus 1/10 is 3/20th. So that will be 3 over 20. 3 over 20 is less than 1 over x, because when you add 1/4, that get canceled. And this side, it will be 1/4 plus 1/10. Okay, 1/4 plus 1/10, which is equal to 7 over 20. 7 over 20. We are not interested in 1x. We are interested in x. That means I have to take the reciprocal. So if we take the reciprocal, this is equivalent to, if we take the reciprocal, that will be 20 over 3, right? 20 over 3 is greater than x is greater than 20 over 7. Because if we take the reciprocal, the inequality sign will flip. So basically what we are saying is your x value is between 20 over 7 and 20 over 3. So 20 over 7 is here. So this will be 20 over 7, the smaller one. And this is the bigger one, which is 20 over 3. So that will help you to find your delta 1 and delta 2. So delta 1 is, you can see, delta 1 is 4 minus 20 over 7. Okay, 4 minus 20 over 7, which is equal to 8 over 7. And delta 2 is this distance here, which is 20 over 3 minus 4. 20 over 3 minus 4, which is equal to 8 over 3. So we get two values. One is 8 over 7 and other one is 8 over 3. Those are delta 1 and delta 2. But I told you delta is the minimum of those two values. Minimum of 8 over 7 and 8 over 3, the smaller of them. Okay, and we know that, 8 over 3, the second one is 8 over 3. Let me write that clearly. 8 over 7 and 8 over 3. So you can see that 8 over 7 is smaller. So meaning of that is your delta is 8 over 7, because 8 over 7 is smaller than 8 over 3. Remember, if it was a symmetrical interval, we get delta 1 and delta 2 the same. So we don't have to look for the minimum. But in this case, the delta, this interval is not symmetrical. You can see that the delta 1 looks smaller and delta 2 looks bigger. And clearly, it is smaller here. 8 over 7 is smaller. So the smaller of the two deltas is the delta value that is required. So this is how we can solve the problem involving the definition of limit. We call it epsilon delta definition of limit. So your 0.1 is the epsilon and the delta is 8 over 7. So this is how we can handle the problem involving limit at infinity, infinite limit, continuity, intermediate value function, intermediate value theorem, and the epsilon delta definition. So that's all for this little video. I hope you find this helpful. Thank you so much for watching.